Hi guys, so I'm gonna do the demo I did in class that you can easily do also at home. So here I have a magnifying glass that I got at the dollar stores. It's a converging lens, that is, it's a convex lens. And if I am, so that's my screen here, and you can see the outside. Okay, you see the outside that is far away. You can see it upside down here on the screen. So the image is inverse. It's going to be real because it can be displayed on the screen. And what is interesting about it is that the distance between the screen and the lens, that's going to be the focal length. So that's one way to find the focal length in a very, very fast and easy way. See, you can try to focus, you see the building upside down. So that means that parallel rays coming from far away are all going to converge at a single point. Okay, so every single point from far away is converging at a single point here at the focal point at the focal distance. Hi guys, so that's going to be the same converging lens, and now the object here is inside the focal length. Okay, so smaller, that distance here is smaller than the focal length. So that converging lens is now able to magnify. See, it's magnifying. So that means the image that you see is in the same size than the object, right? So it's a virtual image that your eye is able to see, and that image is upright. Okay, it's not upside down. It's guys, so here's another demo I did in class. So I still have my converging lens. Here you have the object, which is just a arrow, and it's pointing in this direction, right? So for me it's to the left. And now you have the screen here. There is nothing on the screen, just light from my computer. But now I'm going to place the lens in between the computer and the screen, and you see that now the arrow is pointing to the right? I mean the opposite. So for me here it was pointing in this direction, and now the arrow here is pointing in the opposite direction. So what do I get? I get image which is real because it can be displayed on the screen, and it's inverted and it's smaller, right? So I could move, for example, if I move my computer, if I move the computer closer, you see the arrow here is getting larger. Okay, and if I move it really, really close, now I don't see anything because you have a virtual image. Very close, I cannot get anything here. You see it's still real, inverted, and in that case bigger, because the distance between the object and the lens is in between 2 times the focal length. Guys, so you see that I could also replace the lens. I could replace it with water here inside that container, and it will also behave like a converging lens, because it's not perfect, but I still get the image here on of the arrow, and it's pointing to the opposite direction that I have here on my screen, which is the object. So here I get an image which is smaller, inverted, but it's real. Another thing that you can do, which is fun, and another thing that is fun to do, you see this arrow here is pointing to the left, and that's an experiment that was given by a student of mine. His name is Alex. So here it's pointing in this direction. Now if you look through the glass here, which is filled with water, it's pointing in the opposite direction, right? So that means you get an image inverted image, and this is behaving like a converging lens.